We're at the Seal Cove Auto Museum to look at a Knox that they're rebuilding. We're looking at a 1904 Knox at the Seal Cove Auto Museum that's undergoing some restoration work. Let's take a look. They've taken off the body, made in Springfield, Mass. One of the unique features are the air-cooled cylinder heads, sometimes called porcupine heads. Notice all the screwed-in studs that are cooled by a fan at the end. This car has two cylinders, one in the front, there's the crankshaft, and a cylinder in the back. The reason this is a part today is because there's an auxiliary 1-inch shaft that runs the length of the car, driven by a spiral gear. The gears aren't lubed, and they're exposed to dirt, and they wear out. That auxiliary shaft does several things. It drives the fans at either end, and it activates the exhaust valve. Oh, and it also controls the ignition.
On this side of the engine, we've got an atmospheric intake valve. By atmospheric, what that means is this lightweight spring is all that keeps that valve in the closed position, and the cylinder's intake stroke pulls the valve open. You do it easily to think of. This isn't a Valvetrain mechanism. This is just a compression release. So while cranking the engine, you can release that compression, but otherwise there's literally no Valvetrain. The intake valves on the other side is an exhaust valve, and that part of the Valvetrain is missing because we've got it apart right now. But that's an exhaust valve with no spring. It is simply pushed open and pulled closed by a mechanism that's driven by an auxiliary shaft that we've got removed right at the moment.
So this car is steered by a tiller rather than a steering wheel.
Its shock absorbers down here on the steering box. I can show that action. With the rough roads, there's a little bit of a shock absorber that's jar through the tiller handle.
This car has the crankshaft connected to a planetary gear set, and that gear has several bands. In high gear, this is a direct drive right to a chain, but another band will actually activate low gear or reverse. The chain goes to a back differential, which splits the power between both rear wheels. There's also a band brake hooked onto the differential. This car has a chain drive.
Now we got to get a bigger. Is that bigger right here? Is that the same?
And to adjust the chain, we actually move the entire axle backwards a little bit. Driving the car, there are three levers. One's the tiller. One goes to the planetary gear set. But the other small lever actually controls both spark advance and the carburation. We can see the carburetor being adjusted. This car has a bronze front axle and numerous oil fittings. Peter's busy oiling the front end right now.
Even without fittings, there's a pivot point here for the springs. The springs are odd. They run the length of the frame. That's worth a shot. And what about this grease cup? So here we've got a grease cup packed with grease. It threads and applies grease inward through the crankshaft, past the planetary gear set, frighteningly, into that main bearing, which is a Babbitt bearing, of course. That is greased, no oil pressure at all, greased. And that same grease goes down to the big end of the connecting rod, which is spooky because that's the source of lubrication for it. Keeping in mind that this engine at high speed runs 700 RPM. The only other lubrication is these oiler supply tubes that oil and drool oil into the skirt at the base of each piston bore. And then this open crankcase has a tin cover over it, but it's otherwise just open to the atmosphere. An occasional twist here lubricates the main journal and the rod on this side. The other end of the crank with its hollow drilled passageway has there's a grease cup over there too for that main journal and the big rod journal.